All right, so we've already talked about solving one-step equations and solving two-step equations. We've even covered order of operations. Now we're going to start looking at multi-step equations as well as equations that have variables on both sides of the equal sign. So before we get started, today we're looking at a couple different things, and I want to keep going over these vocabulary words because I feel like they're often misinterpreted. I can't tell you how many times I've seen given students an expression to simplify, and students start adding in equal signs and start solving for things. So we want to make sure that when we see these words, we know what they mean. So today we're mainly looking at solving. We're solving multi-step equations as well as equations with variables on both sides. Throughout the process, there's going to be a couple cases where we are going to have to simplify our equations first before we actually solve them. And that just means like combining our like terms, making an expression as simple as possible. So what we're looking at today when we're simplifying is we're going to be simplifying each individual side of the equation as if it's an expression, and then we'll work our way using order of operations to solve. Finally, we have evaluate. We're not looking at evaluating it all today, but oftentimes we'll see evaluate when we're looking at graphing lines, and maybe we are told x is equal to 7. What is y? So we're evaluating. We're substituting in an expression. We're simplifying that expression to come up with a numeric answer. Okay, to review again, we're looking at order of operations. Now, when we are simplifying, we're going to be doing a lot of simplifying before we solve today. We are using just our regular order of operations, grouping symbols, exponents, multiplying, dividing, then adding and subtracting. However, once we start solving, we are doing what we call the inverse order of operations, meaning we are starting from the bottom and we are working our way up. So when we are starting to cancel things out and to solve the equation, we're actually eliminating or canceling out or adding and subtracting first, and then we're working our way up, and the last type of things we would simplify would be grouping symbols. So let's go ahead and get started. So our first example, again, we're solving these equations. We're using inverse operations. So first thing I'm going to do is I'm going to actually draw a line down my equal sign. Now you could do this with one-step equations as well as two, but I don't see this being as big of a challenge when we have those more simple type equations. But oftentimes I really see simple mistakes happening when we don't have that line drawn down our equal sign when we're working with these multi-step equations. Now, if things are on the same side of that line, we are simplifying. So if we look, I'm going to simplify the left side of my equation. I have a 9x and a negative 7x. When I combine my like terms, 9 and negative 7, that's going to give me positive 2x. And then positive 1 and negative 5 is going to get me negative 4. And then carry down my equals negative 20. So this line serves as two purposes. One is it helps keep us organized. It just carries our equal sign straight down. But the other thing is, again, it helps us, I guess, simplify things versus solving. I'm going to go ahead and rewrite it and show you something that I see that's really common that I don't want you to do. So I see 9x plus 1 minus 7x minus 5 equals negative 20. This is a do not do this. Okay, you could still draw your line if you wanted to, but I see people see, okay, well, they have an x and an x, so I'm going to add 7x and add 7x here. And then what happens is we get 16x plus 1 minus 5 equals negative 20. Okay, we do not want to do this. If they're on the same side of this line we drew here on our equal sign, if they're on the same side, we are simplifying. We are combining like terms with the signs that they have. Okay, we only use what we call that inverse operation when they're on opposite sides of the equal sign. So do not do that. Okay, make sure again, if they're on the same side, we take the value that they have. It's a positive 9, a negative 7, which is why we end up with the positive 2x. Okay, let's go ahead and continue solving this. I can't simplify that left side anymore. First term has an x, second term is a constant. They're not like terms. Okay, then I have equals negative 20, which just equals negative 20. That can't be simplified. So now I can solve using those inverse operations. The inverse of negative or minus is plus. So we're going to add 4 to both sides. So on the left side, all I'm left with is 2x. Carry down my equal sign. We have negative 20 plus 4, so we're going to get negative 16. Divide both sides by 2. And so we're left with x equals negative 8. And there we go. Okay, moving on to the next one. There's actually 2 different ways we could start this. I'm going to go ahead and do what I think would be the most obvious way that you would most likely see, and that's going to be our distributive property here. So if I were to draw this line down the middle, or down my equal sign, you can see that when we're distributing, we're not doing something to both sides, right? We're just simplifying that side. So I have negative 7 times 3, so I get negative 21a. And then I have a negative times a negative, so I get positive 7 times 1 is 7. Now I'm going to use my inverse operations to solve. I'm going to subtract 7 from both sides. So I have 91 minus 7. So I get 84 equals negative 21a. Okay, remember, a coefficient and the variable are being multiplied together, so the inverse operation is to divide by negative 21. So divide it by negative 21. And so then I get that negative 4 equals a. Or if you like having the variable on the left-hand side, which I do, you could also write just a equals negative 4, just like that. Okay, let's go ahead and move on to the next example. We're getting a little bit more complicated here. Couple of big things that I want to point out and why I chose these particular problems to use as examples. When we have this negative here, okay, negatives and positives and minus and plus, those can be interchanged. So when we see this, I'm not sure if you ever did this when you were adding integers, but we can keep change. So I can keep the 4m, changes to addition, and then now changes to a negative 5. It's super essential when you have problems like this when you have minus and then a distributive property. You're going to see that same thing happen on example number 4. We need to make sure that we're distributing that negative. I also want to point out another common error that happens here. When we think we're looking just at this left side right now, right? All of this stuff is on the same side of the equal sign. If we think order of operations, because we're just simplifying here, we're following our order of operations in order. Parentheses, exponents, multiply, divide, then lastly, add, subtract. Well, when we're distributing here, we're actually multiplying. So I cannot, well, first of all, they're not like terms, but I cannot take the 4m and the 5 and add those together first. I have to distribute first because multiplication comes before addition. So I'm going to carry down my 4m, distribute that negative 5. So I have negative 5 times 3, so I get negative 15m, minus 5 times 10 gets me 50. And it was minus because I had that negative 5 times that positive 10. Again, there's more than one way to do these, but I'm always going to say when I do these problems is to simplify first. So I can still simplify this left-hand side. I have a 4m and a negative 15m. When I combine those, I'm going to get negative 11m minus 50 equals 126. Now, negative 11m and negative 50 are not like terms. One has an m, one doesn't. 126, well, that's the only number over there. There's nothing else I can simplify. Now here's when I'm going to use my inverse order of operations to solve. So I'm going to add 50 to both sides. So I get negative 11m equals 176. Okay, because inverse of subtraction is addition. Inverse of multiplying is dividing. So divide both sides by negative 11. So I'm going to get m equals, well, positive divided by negative is going to get me a negative. 176 divided by 11 gets me 16. Okay, next example. Okay, Again, two things I want to point out here. One is we have this negative again here. We want to make sure that we're taking this negative and we're distributing it. But the last one said -5. This one doesn't have a number. Well, just like this k is the same as 1k, this is the same as saying a -1 here. So we're going to distribute this -3 here. We always stop distributing when the parentheses stop. And then we're going to distribute this -1 here. So I'm going to get -3k plus 24. Because I have a negative times a negative. -3 times -8. Now I have -1 times k. So that's just going to get me -1k minus 5. So this negative in front, since it's -1, distributing, all that's really doing is changing my signs here, equals 23. Now I'm going to combine my like terms. They're all on the same side, so I'm still simplifying here. -3k and -1k get me -4k. And then positive 24 and -5 are going to get me positive 19 equal 23. I'm going to subtract 19 from both sides because I'm done simplifying. -4k equals 4. Divide both sides by -4. And k equals -1. Again, don't forget, we always want to make sure we distribute that negative there. Okay, so those were examples. We were looking at these last 4 examples. We are working on multi-step equations. So we had a lot of steps here going on. Now we're going to go ahead and look at variables on both sides. So we can start with either one. I always start with the variables. So there's nothing I can simplify. Each side has one variable and one constant. I always like keeping positive numbers if I can. So what I'm going to go ahead and do, these are both positive 5y and positive 3y. Inverse of positive would be negative. So in order to keep the numbers positive, I'm going to subtract the smaller number. So I get subtract 3y on both sides. So 5 minus 3, so I get 2y minus 8 equals 12. Now I want to get rid of my constants or simplify my constants. So I'm going to add 8 to both sides. So I get that 2y equals 12 plus 8 gives me 20. Divide everything by 2. So I get y equals 10. Okay. Now, these were all positive y's. If we look at example number 6, I actually have a lot of negative variables, negative x's. So I'm actually going to cancel out the larger variable first. So here's my middle line. I can't simplify anything. So I'm going to solve. I'm going to add 8x to both sides. I chose the larger number this time because they're both negative. When I go back now and add the numbers, I want to add the larger number so that those negatives all cancel out. So -6 and positive 8 get me 2x. Carry down my plus 14, and then equals 12. I'm going to subtract 14 from both sides. We get that 2x equals -2. Be careful here, we're subtracting a larger number. Divide both sides by 2. X equals -2 divided by +2 gets me -1. Let's look at a couple more examples here. We have variables on both sides again, but we have a little bit of distributive property to do here. So first step, simplify. So let's go ahead and distribute. I'm going to draw my line here down the middle. So 3 times 6, so I get 18p minus 3 times 1 is 3 equals 11p minus 45. I distributed, that helped me simplify, but there's nothing else I can simplify on either side. So now I get to use my inverse operations and solve. So I'm going to go ahead and subtract 11p from both sides. 18 minus 11, so I'm going to get 7p minus 3 equals -45. add 3 to both sides. So I get 7p. We have to be careful with our signs here. Negative 45 plus 3 is going to be negative 42. Now I'm going to go ahead, inverse again, divide both sides by 7. This is actually a problem, the 42 divided by 7, I will never forget. When I was in 4th or 5th grade, I had a teacher that every time we came in from lunch, or every so often when we came in from lunch, we had to answer like a multiplication question or something going into the classroom. And my question was 7 times 6. And I got it wrong. So I had to go all the way to the back of the line and I had to do another one. So I was one of the last people in from lunch. So 7 times 6 equals 42. That is one that I will never forget. So we had the negative 42 divided by 7. We got that negative 6. Okay, on problem number 8, excuse my parentheses here. I fixed it if you didn't see there. So we have, again, those simplification things we need to do. We need to make sure we take this. Remember, it's a negative 1. We're going to have to distribute that. And then we're going to have to distribute this negative 2 here as well. So carry down my 5x. So minus x plus 18. That negative in front just switched my signs. And then 6 minus 2x minus, not 15, 2 times 15 is going to get me 30. Now, first I'm going to simplify. I have 5x minus x. That's going to get me 4x plus 18 equals. On the right side, I have positive 6 and negative 30. So first I'm going to write my negative 2x. Negative 30 and positive 6 is going to give me negative 24. Now I like doing my variables first. I'm going to go ahead and add that 2x to both sides. 4 and 2, so I get 6x plus 18 equals negative 24. Subtract 18 from both sides. I get that 6x equals, well, they're both negative, so really I'm actually just adding the numbers together. So I get negative 42. Divide both sides by 6. And we get that x equals, here's my favorite multiplication or division problem here. Negative 42 divided by 6, we get negative 7. All right. Last two examples, we have what we call no solution versus infinite solution. It's possible not to get a solution. So up until now, all of those problems, we've had one solution. So let's see what it looks like when we have no solution or infinite solutions. So both of these have variables on both sides. So we're going to go ahead and just solve them like we normally would. So first I'm going to simplify. I'm going to go ahead and distribute here. So I get negative 8x minus 4 equals negative 8x minus 2. Again, I like doing the variables first. So I'm going to go ahead and add 8x to both sides. Well, negative 8x and positive 8x, I have that exact same thing twice. Those are going to eliminate. So right now I have negative 4 equals negative 2. Does that make sense? Is negative 4 equivalent to negative 2? No, it's not. So I'm going to change this to a not equal sign. And so this is when we have what we call no solution. It doesn't matter what number I substitute in for x, it's never going to end up being an equivalent statement. Okay, so that's what we could write out no solution. The shortest way to write no solution is a 0 with a line through it. So be careful. If your answer is 0 and you're in the habit of putting lines through your zeros, be careful because a 0 with a line through it by itself means no solution. So either of those would be acceptable answers. Either write out no solution or that 0 with a line through it. Which means if you haven't figured out, this is going to be an infinite solutions. So let's see what that looks like. So I'm going to draw my line down my equal sign. Let's distribute here. Copy down my left side. So 3 times 1 is 3 minus 9x minus 9. Okay, on this right-hand side, I can simplify. I have a positive 3 Okay, I'm in a negative 9. So I'm going to copy my left side, negative 5 minus 9x equals, 3 and negative 9 give me negative 6 minus 9x. Same thing, I'm going to get rid of my variables first, add 9x, and actually I'm realizing as I'm doing this, I had a typo, and I'll show you guys what that is in a minute. And what it really should look like is no solution. The 9x's are going to cancel out again. I'm left with negative 5 equals negative 6. Again, that doesn't make sense. So this would actually, again, be a no solution. Or again, that 0 with a line through it. What would end up being something like infinite solutions, if I were to take that problem and if I actually had negative 6 minus 9x equals negative 6 minus 9x, what should have happened when I originally typed it is this should have been a negative 6 here first. And so when I would have added the 9x to both sides, I would have had negative 6 equals negative 6. That makes sense. Those are equivalent. Negative 6 is equivalent to negative 6. And that's actually where we would have infinite solutions. Or we can put an infinity sign. Either one would be fine. What infinite solutions means is that no matter what value I substitute in for x, it's going to work out every single time. If you notice when we simplified here, when we looked at this actual infinite solution one, without my typo, we saw that when we simplified, all the variables actually canceled out, and we just ended up with negative 6 equals negative 6. So no matter what I substitute in for x, I'll still end up getting something that's equivalent. I'll still end up with an equivalent statement. Okay. So today we covered solving multi-step equations, which included variables on both sides. And then we looked quickly at what it means to have no solution versus having infinite solution. If you guys have any questions, please let me know.